Hi students, today we are going to discuss about angular dispersion and dispersive power of a prism. So this is the principal section of a triangular prism ABC. AB and AC are two refracting phases, and the angle between AB and AC is the refracting angle of the prism. So this capital A, if it is of the order of 10 degree or less than that, then it is called a small angled prism. So for a small angled prism we are going to discuss now. When a ray of white light, that is also called as composite light or polychromatic light. White light is a composition of so many wavelengths, is it not? So it is also called as polychromatic light. So what will happen when a ray of white light is incident on a prism? It will disperse into 7 colors. So the emergent light contains 7 colored rays, and this is called as the spectrum, called visible spectrum. We remember by the acronym VIBGR, is it not? VIBGR: violet, indigo, blue, green, yellow, orange and red. And also we can see that these emergent rays, namely red to violet, the extreme colors red and violet, if you observe, means they have deviated from the original direction through some angle. So if I produce this incident ray by a dotted line, okay, like this, a dotted line, that is the direction of the incident light. So with respect to the direction of the incident light, due to the presence of the prism, the violet and the red, including the other colored rays also, they have deviated from the original direction through some angle. You watch this diagram and you try to understand the deviation for red and the deviation for violet are different first of all. So which color has deviated less and which color has deviated the most, we are going to find out. So this red has deviated by a small angle which is denoted by delta R, deviation for red. So delta R represents deviation, okay, of red color or red light. Similarly, with respect to the original direction through a very large angle, who has deviated? It is violet. So this angle is delta V. So delta V represents the deviation of violet light. Why this deviation is different for different colors? This is because the speed of light, is different for different colors inside glass. Okay, so red light is traveling with greater speed inside glass, and violet is traveling with less speed inside glass. Understand? Also, the refractive index of the glass is not the same for all colors. It is different for different colors. Okay. Now, in general, the refractive index, okay, the refractive index of the material, of the prism is given by the expression n equal to sine of A plus D divided by 2. Here I am going to take the deviation for the colors as a symbol small delta, okay, and this is divided by sine of A by 2. This is a general expression just now we have derived for the material of the prism. Okay, what type of prism we are discussing here is a small angled prism. This angle is less than 10 degree or up to 10 degree. So when the angle of the prism is very small, these two deviations also will be proportionately small. Understand that? Therefore, here this sine of A plus D is nearly equal to A plus D itself, and sine of or I can write this is A plus D by 2 itself. Okay, sine of A by 2 is nearly equal to what? A by 2 itself. Because when theta tends to 0, understand? Sine theta by theta is equal to 1. In mathematics you must have studied. So when the angle A as well as deviation delta both are very small, means sine of the angle is nearly equal to the angle itself. Okay, so I have written sine A plus D by 2 is equal to sine, that is A plus D by 2. Similarly, sine of A by 2 is nearly equal to A by 2. Therefore, I can write the refractive index of the material is equal to A plus delta divided by 2 whole divided by A by 2. So this denominator 2 can be cancelled, and n is now equal to A plus D divided by A. So these two get cancelled. So n into A is equal to A plus D, or D is equal to NA minus A, or D is equal to A into n minus 1. So this is one of the important steps. This equation is to be remembered by you so that you can solve the numerical problems in the MCQs. Okay, in the competitive exams, this equation will be directly used in numerical problems. So now for violet, deviation for violet is written as refractive index for violet minus 1 into A, and deviation for red is given by refractive index for red minus 1 into A. As I told you already that the angle of prism is the same. Prism is the same for any color, and the refractive index of the material only is different for different colors. Hence, the deviation also is different for the different colors. Okay, so these are considered as equations 2 and 3. So what is the delta V means? It means the deviation of which color? Violet color. And delta R means what? It is a deviation for the color red. So this difference in the deviation, delta violet minus delta R. Okay, so this difference in the deviation, so right hand side is NB minus 1 into A, okay, minus NR minus 1 into A. So this difference if you find means delta V minus delta R is equal to NV minus NR into A. So this will be the equation available for us. This is equation number 4. The left hand side of equation 4 is only called by the name angular dispersion. So what is the definition for angular dispersion for a prism? It is defined as the difference in the deviation for the two extreme colors. Which are the two extreme colors? Violet and red. So deviation is most or maximum for violet and minimum for red. This difference in the deviation between violet and red colors only is called as what? The angular dispersion. So this equation 4, after 1, this equation 4 also is very important to solve the competitive exam MCQs. So angular dispersion dV minus dr, or delta V minus delta R is equal to NV minus NR into A. Understand? So this is equation 4, which is called as angular dispersion. Okay, now you see that red color and violet color. Out of these colors, which is the short wavelength is violet and long wavelength is red. All other colors have wavelength in between that of red and violet. Now, on an average, which color is having the mean wavelength? If you ask me, it is either yellow or green we can take. So, yellow or green can be assumed to have the mean wavelength. Okay, it lies in between the two extreme colors. Therefore, delta represents a deviation, the corresponding deviation of the mean wavelength, the mean lambda. The deviation for yellow or green can be denoted by the symbol delta. Understand? So, this delta for mean wavelength is equal to n minus 1 into A, where n is the refractive index of the prism for the mean wavelength, either yellow or green. Okay, mostly yellow you can substitute. Okay, delta yellow is equal to n yellow minus 1 into A you can write. If you want, you can also write the symbol yellow here for the mean wavelength. Understand? Okay, students, now if you divide this dV minus dr, the angular dispersion, by delta yellow, then this only is called as the dispersive power. The dispersive power. Now, different prisms are available. The prism may be made up of Pyrex glass or crown glass or flint glass. The refractive index for these different glasses are different. When the same white light is allowed to pass through different prisms, the ability to split the white light into 7 colors will not be the same. It depends upon a quality which is called as dispersive power. Name itself suggests, is it not? Dispersive power is what? The power of dispersing the light in a better way. So, how do you define dispersive power of a material? Dispersive power of a material is defined as the ratio of two quantities. Is it not? It is the ratio of the numerator to that of the denominator. What is in the numerator? Numerator is what? dV minus dr is called as what? Angular dispersion, and delta y is called as what? Deviation for the mean wavelength. So how do you define the dispersive power? The dispersive power of a material is defined as the ratio of the angular dispersion for the two extreme colors are shown here. Is it not? The two extreme colors. To whom? To the deviation of the mean wavelength. To the deviation of the mean wavelength. Okay, this is for definition. We have taken the numerator as the two extreme colors. Sometimes in the competitive exams, you can very frequently look at this type of questions. Find the dispersive power for the colors green and orange, like that they will give. So you have to substitute those two colors only, not only the extreme colors. Understand? For definition purpose, standard definition, we are assuming that the numerator is the deviation between what? The difference in deviation between violet and red. But for any two colors also they may ask in the numerical problem. Be ready for that. Anyhow, my dear students, now you will see that the dispersive power of a material is defined as the ratio of the angular dispersion for the two extreme colors to the deviation of the mean wavelength. Now, instead of delta y, I am going to substitute in the denominator, and instead of the angular dispersion, I am going to substitute this also in the numerator. Therefore, this is denoted by the symbol omega. Therefore, omega, the dispersive power, is equal to, in place of dV minus dr, I will substitute n violet minus n r into A divided by n, okay, yellow minus 1 into A. A gets cancelled. Therefore, dispersive power omega is equal to NV minus NR divided by N yellow minus 1. Now, NV and NR, these are the values of the refractive indices. Is it a refractive index is having no unit? Refractive index is sin I by sin R, so it has no unit. Therefore, here numerator also has no unit. Denominator also is having no unit. So, here it does not have any unit. But is there any unit for the angular dispersion? You check. Angular dispersion is what? Deviation for violet minus deviation for red. It is some angle. So, this can be expressed in degree. Okay, this delta. Okay, delta V minus delta R can be expressed in degree or radian. Whereas omega is not having any unit. It does not have any dimension also. So, my dear students, what are all the facts you must remember here? when a ray of white light is incident on a prism, it gets split into 7 colors, namely VIBGR, violet to red. The two extreme colors are violet and red. The deviation will be different for all the different colors. The deviation will be maximum for violet and minimum for red. This is because the speed of light is minimum for violet inside glass and maximum for red inside glass. So the difference in the deviation between the two extreme colors only is called as the angular dispersion, and if it is divided by the deviation for the mean color or the mean wavelength, namely yellow or green, this ratio only is called as the dispersive power of the material of the prism. I hope you must have understood well. Fine.